Good afternoon, everyone. Welcome back. Okay. Yes, good afternoon, Rohan, Gunjan. Yes, good afternoon so much. Okay, so we are going to study now the third theoretical distribution. We've already studied what? We have studied the binomial, we have studied the Poisson. These two were theoretical distribution for discrete variables. And today we are going to use the most commonly used distribution, that is for continuous variable, that is the normal distribution. Okay, and before we go into that, okay, as we have already been talking about this theoretical distribution and its importance, why we are studying is that this frequency distribution gives us a number of times a data point occurs, whereas the probability distribution will give us when whether or not the data point will occur. It is used for short-term projections, and then it is used statistical for statistical analysis. Okay. Now, probability distribution will also have a mean, median, and mode, standard deviation, etc., like a normal frequency distribution. As already told, discrete distributions are binomial and Poisson, and normal distribution is a continuous distribution. Okay. And before we go forward, I would like to do this sum, which I forgot last time. So, and I find that this is interesting and this will clear more of your doubts. Okay. The standard deviation of a Poisson variate is 1.732. Okay. So they have already given you that sigma is equal to 1.732. What do we know about a Poisson? In Poisson, it is uniparametric. And what is the parameter? M. And what is M equal to? M is equal to sigma square. Okay. So this will be equal to 1.732 whole square. What is the probability that the variate lies between minus 2.3 to 3.68? Okay. Now what is 1.732 whole square? 1.732 whole square is 2.9998. Okay, which is very near to 3. So from here we get M is equal to 3. Now we know that for a Poisson, Px is equal to e raised to minus m, m raised to x upon x factorial, right? So we already know this, and here now we have m as 3. So this distribution becomes e raised to minus 3, 3 raised to x upon 3 factorial. What is 3 factorial? 6. So this is 1 upon 6 e raised to minus 3, 3 raised to x. Okay. Now what they are saying that the variate will lie between minus 2.3 and 3.6. So P minus 2.3 less than or equal to x less than or equal to 3.68. What does this mean? This means, because we already know that x cannot be negative, x can be 0, 1, 2, 3, 4. So this will be equal to P of 0 plus P of 1 plus P of 2 plus, now how much is this? This is 3.68. So I can also take P of 3. Okay. So, and then this is the normal substitution and you can solve the sum. Main thing here is these are the two main points that you should remember here is that this point where you're saying m is equal to sigma square, and the second point is that this means what? Because we know from minus 2.3 to x, there will be nothing but till 0. You don't have the Poisson, then you will have P of 0 plus P of 1 plus P of 2 plus P of 3. And then you substitute here. So this will be equal to e raised to minus 3, 3 raised to 0. Okay. 3 raised to 0 upon 6. This is 6 here, 6 into 0 factorial plus e raised to minus 3 3 raised to 1 upon 6 into 1 factorial plus e raised to minus 3, 3 square upon 6 into 2 factorial plus e raised to minus 3, 3 raised to 3 upon 6 into 3 factorial. Okay, so this is how you're supposed to do it. Okay. Yes, Lakshita, Ishan, Diksha, Bhumika, Zeba, Rahul, Chahal, Rohini, Rekha, Soumya, Sagar, Divya, Faizan, Jyoti, Sonali, Zeba. Oh yes, X factorial. This will be X factorial, no 3. 3 will be coming here. So this will be upon X factorial. Okay, here. This is X factorial. So this will be here 0 factorial, 1 factorial, 2 factorial and 3 factorial. Okay. So thank you, Zeba. So here you will be solving it in this manner. Okay. And then you just have to substitute 3 e raised to minus 3 is already given to you as 0.0497 and that you can substitute and find out the value. Okay. Now coming to normal distribution. Yes, Sakshi, Swati, good afternoon. Yes. Okay. So the normal distribution. So a continuous random variable x is defined to follow normal distribution when it can be described by parameters mu and sigma square. Sigma square is what? Variance. And what is mu? Mu is the mean. Okay. And we write it in how? Like we write it x is described by mu and sigma square. Okay. Then if the probability distribution function of the random variable is given by, okay, just f of x is equal to 1 upon sigma, and this is square root of 2 pi. Okay. In sometimes you may feel that I will write it later on, sigma. But then remember it is not under the square root sign. Okay. So 1 upon sigma under root of 2 pi into e raised to minus x minus mu whole square upon 2 sigma square. Okay. And what will be the value of x? X will go from minus infinity to plus infinity. Can you see the difference now? From minus infinity to plus infinity for the continuous variable. So the probability density function fx is given by 1 upon sigma square root of 2 pi e raised to minus x minus mu square whole square upon 2 sigma square. Now e value we already known as 3.72. What is the value of pi? It is also written like this in some books on like this. This is simply equal to 22 upon 7. Okay. And where mu and sigma are constant and sigma is greater than 0. Okay. This is also a condition that can be asked in the theory. So here we are talking about normal distribution for a random variable with parameters mu and sigma square. And here what is the fx? Fx is equal to 1 upon 2 under root of 1 upon sigma under root of 2 pi into e raised to minus x minus mu whole square upon 2 sigma square. Okay, some important points relating to normal distribution are given there. So the first is general. The name normal distribution has its origin some 200 years ago where mathematicians were in search of a normal model. Okay, so that is nothing important. This is very important. We plot the probability function y fx, then the curve is known as the probability curve. Okay, so this is the probability curve. On y-axis, you are plotting the probability, and on x-axis, you are plotting the variable values. Okay, so this is the normal distribution. Now here itself we can see what are the characteristics. It is bell shaped. Okay, it is symmetrical. Okay, and you can see that these lines. Okay, these lines. These are going like this. They are not. You are not having directly. It is not touching the axis. So the lines don't touch the x-axis. Okay, and it is symmetric about mu. So all this, just by looking at the graph or the curve, you should be able to deduce so many things. And here you can see this is concave curve, and after that it becomes convex. Okay, so it is like this, and then it becomes like this. So up till here, this is concave, and after this, this is convex. Okay, concave and convex. If you remember, maybe in class 10th, you studied in physics, lenses, the chapter of lenses. Those of you who are from CBSE and ICSE, they must be having it. So convex lenses, concave lenses. So that is the meaning. And if you don't know, just remember that earlier it is concave and then it becomes convex depending on the shape. Okay, this probability function is known as probability curve here. Now, let us see. A quick look gives that the normal curve is bell-shaped. We already talked about that. It has one peak. Second point, it has a unique mode. The line drawn through x is equal to mu. So this is x is equal to mu. This is the line through it. Divides the normal curves into two parts which are equal. Okay, so equal parts. Okay, these two are equal. Then we find that the normal distribution is symmetrical about x is equal to mu. Okay, these are theory questions. Okay. So the normal distribution is symmetrical about x is equal to mu. Binomial distribution is also symmetrical about p is equal to 0.5. Okay. Also, the normal curve extends indefinitely on both sides, and both the left and the right tail never touch the horizontal axis. Okay. They may give you certain points and ask whether true or false. So here you will note that both left and right tails, these are known as tails. Okay, these are known as tails. This is also tail. They do not touch the horizontal axis. Sixth, the total area of the under the normal curve is always equal to 1. Total area under the curve is always equal to 1. And since this line is dividing, so this will be 50% of area, and this will be 50% of area. Okay. So what are the things we have done till now? We have talked about the formula. The formula is fx is equal to 1 upon sigma under root of 2 pi into e raised to minus x minus mu whole square upon 2 sigma square. Okay. This is one point. Remember that sigma has to be greater than 0. Mu and sigma are constant. And here x lies from minus infinity to plus infinity. Okay. Then we are talking about the probability curve. There will be points of inflection. These points of inflection are where the concave curve becomes convex and when the convex curve becomes concave. Okay. Then remember that this probability curve is symmetrical about x is equal to mu. Then it is bell shaped. It has one unique peak. So it has one unique mode. Then the line will divide the curve into two equal parts. Then the left and right tails never touch the x-axis. and the total area under the curve is equal to 1. Okay, I hope you've understood till now. So the area between, see the total area under curve is equal to 1. Therefore, area between minus infinity to mu is equal to 0.5, and area between between mu, that is 0 to infinity, will be also equal to 1. Okay. The next point, before we do that, let me check. Yes, Bibhu, good afternoon. Yes. E3 is mean. Gurleen, where are you talking about? Okay, just put it again, your question. Bala, Shivangi, yes, very good afternoon. Yes, Lakshita, it has one peak, Maida. Good afternoon. Yes, very good. You understood? Yes, Zeba, Sagar have understood. Okay. So, once again, we'll write down the formula. What fx is given by one upon 1 upon sigma square root of 2 pi into, this is 1, e raised to minus x minus mu whole square upon sigma square 2 sigma square. Okay. Now, if we take mu is equal to 0, if we take mu is equal to 0 and sigma is equal to 1, so instead of sigma, I'm going to write 1. Instead of mu, I'm going to write 0. So let us see how it would look like. 1 into square root of 2 pi e raised to minus x minus 0 whole square upon 2 into 1 square. Okay. So this is written as this. At this condition, we put x is equal to z. Okay. This condition will exist at some point, and that point we call it as z. So this will become 1 upon, so this becomes f of z, because this is happening at a particular case, is equal to square root of 2 pi e raised to minus x square upon 2, minus z square upon 2. Okay. And z is also going to lie between minus infinity to plus infinity. Okay. Have you understood this now? That it will lie between minus infinity to plus infinity. So what we have done is, here we have substituted, this is important, we are substituting mu is equal to 0 and sigma is equal to 1. When we do that, when we put mu is equal to 0 and sigma is equal to 1, the random variable z is then called as standard normal variate. It is called as standard normal variate. So that when they tell you that this is a standard normal variate, remember that they mean here is that z, where what is z? That is the condition that mu is equal to 0 and sigma is equal to 1. Okay. And this is how they've written. Okay. So don't get confused with the symbols, or in some books you may, if you are referring to some other book also, so symbols may be different, but the concept has to be the same. Okay. We also have mu of 0 is equal to p, x is less than or equal to 0, which is the area of the standard normal curve between minus infinity and 0. Okay, so if I'm talking like this, okay, then when I'm saying x less than 0, this side, okay, x is less than or equal to 0, that means from this, that means from here, I'm going to this side, okay. What is the area? Area will be 0.5, okay. And that is why we say that sigma of 0 is equal to 0.5. Okay, you don't have to understand or you don't have to write down the how this phi of 0 is 0.5, but you only need to understand it. Okay, just keep it in your head, and if it is still more confusing, just remember that phi of 0 is 0.5. Okay. Again, the normal distribution curve is known as biparametric. Why? Because it is defined by mu and sigma square. There are two parameters, so it is called as biparametric. Okay. Once these two parameters are known, the normal distribution is completely defined. Okay. So these are the 4 points that we covered right now. These are 6 points, and then after that we are talking about here. When mu is equal to 0 and sigma is equal to 1, we say that the random variable z is known as standard normal variant. Okay, properties. Since pi is equal to 22 by 7, okay, so here always remember fx is always greater than or equal to 0 for every x. Okay, so in wherever you see this symbol, it means for every. Okay, so this property also you always remember that f of x will never be negative. Also, we that when I add all these probabilities going from minus infinity to plus infinity, fx is always equal to 1. Remember, in binomial and Poisson we have written summation fx is equal to 1 because it was discrete, so we calculated for each value and then we added it, and that came to 1. Here we have a continuous variable, so I will have to find the integration. Integration is going to add small pieces together and form the whole structure. So sigma integral minus infinity to plus infinity of fx is equal to 1. Okay, it is properties are similar, but the way they are presented are different. So don't feel that you are getting so many new things. Okay. Lakshita, why we put 12 in case of variance is equal to 12? Where did I put 12? Good lean, what do you want? Poison sum. Okay. Lakshita, just let me know where you are thinking. Okay. See, remember yesterday's? This is your formula for Poisson. Okay, this is your formula for Poisson, right? Remember, fx is equal to this. Now, what is given to you in 16.18 that we have taken just now? Just let me check. We are taking 16.13, right? Eleven, 12, 13. Okay. So you remember this formula now, Gurleen? E raised to minus m raised to x upon x factorial. X is going from where? 0, 1, 2, 3. Okay, I will just solve it here itself. So we are talking about 16.13. Okay, this is the Poisson sum. Okay, please don't get confused. This is not a normal sum. This is a question related to Poisson. Okay. So they are saying standard deviation. They said that standard deviation is equal to 1.732. Okay. So I square this because I know that m is equal to x bar, which is equal to sigma square in case of Poisson, which is equal to 1.732 whole square. Okay. Now this square is equal to 2.99 something. So we give it equal to 3. So we get from this, I get m is equal to 3. Now I substitute over here. But what is the range they are asking? That the variate means x is lying between what? Minus 2.3 less than x less than 3.68. Okay. They are saying the variate, that is x is lying between minus 2.3 to 3.68. But here I know x cannot take the negative values. So on the number line, this is my 0, this is my minus 1, this is my minus 2, this is my minus 3. And here I have 1, 2 and 3. Okay. Now anything below this, I will not take for Poisson. For Poisson, I can take from here onwards. Okay. This side. Okay. I will take only for this side. So therefore, I will for this variate. So when I want to find this is nothing but P of 0 plus P of 1 plus P of 2 plus P of 3. Why do I stop at 3? Because this is 3.68. I can't take 4 because my variate is ending. The limit and the boundary is 3.6. So I can't go to 4. And I need to have discrete variables. So that is why I can take only 0, 1, 2, 3, 4. Okay. So here I can't go to 4. Here I can't go below 0. So therefore this is the most important step for Poisson, because here this reflects your understanding whether or not you remember that Poisson is for discrete, and then Poisson the x value cannot be less than 0. Okay, so those are very important points that you have to apply when you are solving this problem. The arithmetic part you will be able to do very well. Okay, so this is e raised to minus 3, m is 3 raised to 0 upon 0 factorial plus e raised to minus 3, 3 raised to 1 upon 1 factorial plus e raised to minus 3, 3 square upon 2 factorial plus e raised to minus 3, 3 cube upon 3 factorial. Okay. And then you need to solve this. Okay. I hope this is cleared, Gurleen. Himanshu, where I have not even reached there. Why do you need me to summarize? Okay, yes, I will summarize, no doubt about it. Yes. Okay, I will be summarizing, don't worry. Okay, now we are talking about normal distribution, and you know that it is a biparametric distribution. Why? Because you here you can see that it can be described by mu and sigma square. Okay. Okay. Since Himanshu is asking for, let us summarize till here. So what is a normal distribution? The continuous random variable x is defined to follow a normal distribution with parameters mu and sigma square. And it is denoted by n into bracket mu comma sigma square. Okay, and what is a probability function? It is given by 1 upon sigma into square root of 2 pi into x e raised to minus x minus mu whole square upon 2 sigma square. Okay, just remember this, that x here is going from minus infinity to plus infinity. That is a very different thing than usually we have. Okay, now what we do over here is that when we plot this probability curve, then we call it as a probability curve when we are plotting the probability on the y-axis. So once I plot this, I see that the curve is a bell-shaped curve. Second thing is the tails are not touching the x-axis. It is symmetrical about the mean. And fourth point is it has a unique mode. Then it is since the line is dividing, x is equal to mu is dividing the curve into half. So what is happening? Half of the area will be lying to the left of the line and half of the area will be lying to the right of the line. Okay, and the area under the curve is going to sum up to 1. Okay, that is the second point. The third important point is that total area under the curve is 1. Then this is what we are using a lot. When we put mu is equal to 0 and sigma is equal to 1, then the random variable will be known as standard normal variate. When we put mu is equal to 0 and sigma is equal to 1, the random variable z will be called as a standard normal variate. Okay, and then we substituted and we got this formula. We substituted and got this formula. What does the formula say? Fx is equal to 1 upon square root of 2 pi e raised to minus z square upon 2. Minus z square upon 2. Okay. And sigma x is known as the cumulative distribution function. Okay. Here just remember this is this name. Okay. It is called as the cumulative distribution function. And this is very important because you use this while solving the problem that sigma of 0 is equal to 0.5. Okay. Then the other property is that normal distribution is biparametric. So it is characterized by two parameters, sigma and sigma square and mu. Okay. So quickly, we are saying when a continuous variable is described by mu and sigma square, it follows the normal probability distribution. It is given by fx is equal to 1 upon sigma under root of 2 pi e raised to x minus mu whole square upon 2 sigma square. Okay. So this is the condition in which my x goes from minus infinity to plus infinity and sigma is always greater than 0. The value of E is 2.72 and pi is 22 upon 7. Okay. Then when you plot this, you get the probability curve, which is bell shaped, which is symmetric about x is equal to mu. The tails do not touch the x-axis. There is the unique mode because there is one single peak and the whole area under the curve is equal to 1. The line x is equal to mu divides the area into 2 equal parts. Okay. Then the special condition when we put mu is equal to 0 and sigma is equal to 1, this distribution can be represented by z. Z is the standard normal variate and this is given by 1 upon square root of 2 pi into e raised to minus z square upon 2. And sigma phi of 0 is always equal to 0.5. Okay. So now we go to the properties of normal distribution. Himanshu, okay? Yes, Bhumika, correct. Yes, Diksha, good. You understood? Avdesh, good afternoon. Okay. Now here, what happens is that you will be solving the problems, and in solving the problems, you will be using the biometric metrica tables. Okay. So we will be doing some using those tables also. Yes, as we go along, you will be able to understand. I keep revising in between because so that you will be able to understand better. Okay, don't worry. The mean of a normal distribution is given by mu. Okay, mean is given by mu. Okay, and the good news is that mean is equal to median is equal to mode for a normal distribution. So all of this is equal to mu. Okay, so you for normal distribution, you only have to remember this one property, that mean is equal to median is equal to mode is equal to mu for a normal distribution. Okay, they coincide. Then this, so the first property is that area under the curve is equal to 1. Then and also fx is always greater than or equal to 0 for every value of x. Second is mean median mode is equal to mu. The third property is, okay, now these are the things that you use, this third point, second point are the things you use while solving the problems also. Okay, the standard deviation, the sigma is given, this gives a what? This is equal to standard deviation. Okay. Okay, this gives you standard deviation. So SG is equal to mu. What about mean deviation? What about mean deviation? Mean deviation is given by sigma square root of 2 upon pi. Okay, sigma into square root of 2 upon pi. Now pi is 22 by 7. So 2 upon 22 by 7. Let us try to find out. This is equal to mu into square root of 2 upon 22 upon 7. Okay, so let us try to find out. 7 divided by 11, and then I find its square root. So this is equal to this portion. This portion, when I solve it, this is equal to sigma into 0.7977. So we say that mean deviation is equal to 0.8 times sigma. Okay. So you don't, either you remember this or you directly remember this. Okay. So you don't have to worry. So what we do is we just write this. This calculation I've shown for your understanding, but you even simply have to just remember this. Mean deviation is equal to mean deviation is equal to 0.8 times sigma. Okay. So standard deviation is sigma, then mean deviation is 0.8 sigma. Then we have first quartile is equal to mu minus 0.675 sigma. Q3 third quartile is equal to mu plus 0.675 sigma. Q1 is this, Q3 is this. Okay. Then we have quartile deviation. Quartile deviation is equal to 0.675 sigma. Okay. These are some of the very important formulae that you should always remember while you're trying to solve sums on normal distribution. See, because for 1 mark, 2 marks, this becomes easier for them to ask also, you know, because if they ask you what is the mean deviation when the standard deviation is so much, quickly you need to know only this much. The mean deviation is equal to 0.8 times sigma. Once you know that, you just have to substitute. So they also know that you have understood what normal distribution is and you are able to solve the problems. Okay. So standard deviation is sigma, mean deviation is 0.8 times sigma, Q1, that is the first quartile, is equal to mu minus 0.675 sigma, Q3 is equal to mu plus 0.675 sigma. So, and quartile deviation is equal to 0.675 sigma. Okay. Just make sure that you understood these formulae. Yes, Bibu clearly understood? Yes. Yes, Zeba, Manshu, Avdesh. Yes, very good, Avdesh. The normal distribution is symmetrical about x is equal to mu. We already talked about it. That is why it is dividing the area under the curve into two equal parts. As such, its skewness is 0. Okay, this is also an important. I forgot to underline that. Its skewness is 0. Very important. Okay, theory question. The normal distribution is symmetrical about x is equal to mu and its skewness is 0. That is, the normal curve is neither inclined towards the right, negatively skewed, nor towards the left, positively skewed. Okay. Like in earlier, we have talked about like this. Okay. But here, what do we have? Here you have like this. Okay. So that we know that it is neither inclined towards either of the right or the left. So it is symmetrical and its skewness is 0. The next point is the normal curve has 2 points of inflection. Okay, so this they can ask you in theory also, or they may easily give you a sum. They will give you the mean, they will give you the standard deviation, and they will ask you to find the points of inflection. So what are the points of inflection? That is on the curve, when the curve moves from concave to convex, or from convex to concave. These are the 2 points of inflection. And what are they given by? These points of inflection are given by x is equal to mu plus or minus sigma. So one point of inflection will be mu plus sigma, second will be mu minus sigma. Z is equal to x minus mu. Okay. So here we are saying Z is equal to x minus mu upon sigma, and it is written as n0, 1, where we put mu is equal to 0 and sigma is equal to 1. And it is known as standard normal variate. Now, this is also a very popular question for theory as well as practical is area under the curve. Now, this is my x is equal to mu. This is my point, x is equal to mu. And this line divides into equal parts. Okay. This line divides curve into equal part. Okay. Now, when I go from x is equal to mu plus sigma, okay, from here to here, this is mu plus sigma. Then you have mu plus 2 sigma plus mu plus 3 sigma. Okay. From the mean, I am going to the deviation. Okay. So first deviation is 1 standard deviation, second deviation will be 2 standard deviation, and third will be 3 standard deviation. From the x is equal to mu, I can go on the positive side as well as negative side. So it can be on the left hand side, it will be x minus mu, then x minus 2 mu, and then x minus 3 mu. Okay. Here we are talking about x plus mu, x mu plus sigma, mu plus 2 sigma, and mu plus 3 sigma. X is equal to mu is written as Z is equal to 0. Mu plus sigma is written as Z is equal to 1. Then this is written as Z is equal to 2. And then this is written as Z is equal to 3. That is on the right hand side. What happens if I go on the left hand side? This is written as mu minus sigma, mu minus 2 sigma, and mu minus 3 sigma. Okay. So now we have gone to the left hand side and right hand side. Now here what I do is, then when I find out that from X is equal to mu to mu plus sigma, how much area is covered? It's 34.135. 34.135 of the area is covered. From X plus mu to X plus 2 mu, how much is it covered? It is covering 13.59%. Okay, all this is in percent. So that means from X is equal to mu to mu plus 2 sigma, how much is the area that will be covered? It will be 34.135 plus 13.59. Let us see how much is this equal to. Can I put it in the chat box? How much this is equal to? So then you don't have to worry about the how these formula have come. For that, if you are very interested, you can refer to any statistics book. You will find out how these formulas were generated. Diksha, it is a formula. That's what I'm saying. These are formulas that you have to use as such. Okay, don't have to worry about from where it came. Okay, just use this. Yes, Lakshita, on left all are negative and on the right all are positive. Okay. Okay. Yes. 47.725. Okay, this is on when I'm considering from here to here. Okay, so if I consider from here to here, they are symmetric, right? So if I'm considering from minus mu minus 2 pi to mu minus 2 pi, then this is also going to be 47.725. Okay, if I go from here, x is equal to mu to mu minus 2 pi. If I go from there also, I will get the same because it is symmetric. Okay, so when I'm talking about mu plus or minus 2 pi, I'm getting this. The area under the curve is how much? 95.45%. Okay, that means what? What is the area that is covered? So this is the area that is being covered. From x is equal to mu up to positive and from x is equal to mu to negative side. Then when I'm talking of x from x minus mu to x plus mu, you'll get an answer. X minus 2 mu to x plus 2 mu, you'll get another answer. And x minus 3 mu to x minus 4 plus 3 mu, you'll get another answer. We go up to x minus mu, x minus 2 mu, x minus 3 mu. Because most of the area is covered under this, greater than that, very small amount of area is covered. So that is what I'm trying to tell you, that area covered area between mu minus sigma mu plus or minus sigma and will give you how much area? 68.28. 68.28 Welcome back. Okay, so we are here discussing the area under the curve. Okay, see, I think Saima, you did not understand what this means is, see, the total area under this curve. Let me write it here. Total area under the curve is equal to 1. Okay, total area. यहाँ से लेके आप इसको जाके यहाँ तक जाएंगे तो आपको 1 आएगा. Okay, this line over here, that is x is equal to mu, is dividing this area into half, so that from here to here this is 0.5, okay, to infinity, okay, and from here to here this is 0.5, okay, that area, okay, this is area. Now what happens is, I want to know what is the variation. My mean is what? X is equal to, my symmetry is where at x is equal to mu, that is at the mean. Now as I move away from the mean, there is variation. Now I want to know how much variation is there, okay, how much deviation is there. So what happens, first I move one standard deviation, that is x minus sigma or x plus sigma. On the left I go, I'm over here, okay, I'm over here. From here to I go on my left, this is x minus sigma, and from here if I go to my right, though it is x plus sigma. So one deviation if I move, what happens? What happens if I move 2 deviation? What happens when I move 3 deviations? Okay, that's what we are considering. So if I move from x, if I move from mu minus sigma to mu plus sigma, what is the area that is being covered? See, let me change the color. So from this, okay, that is I'm moving from here to here, because this is mu minus sigma and this is mu plus sigma. Okay, from here to here, how much area will be covered? Here I can see it's written 34.135. This is also 34.135. So that is double that area. Okay, 34.135 plus 34.135, that is 68.27. Okay, this is what percentage of area. Okay, percentage of area. This numbers are given in percentage. What is the area? Okay. Now, what is the area? Area is 1. 68.27% of 1 is what? 0.6827. Both mean one and the same thing. Okay, what is the area covered when I move from the mean to one standard deviation on the left as well as on the right? I am covering 68% of the area. Okay, what will happen if I go to 2 deviations? Okay, not one but 2 deviations. 2 deviations to the left and 2 deviations to the right. So this is mu minus 2 sigma to mu plus 2 sigma. How much will that be? This means from here, this means from here to here. This is for 1 sigma deviation. This is for 2 sigma deviation. So what will happen? 34.15 plus 13.59. Okay. 34.15 plus 34.135 plus 13.59. How much is that? 47.725, but 2 times, okay? Because 1/2 of it is on the left and 1/2 of it is in right. So that is 95.45% of area. What does this mean is, it means that the area that is covered is 95% of the area under the curve will be covered when I move from the mean to up to 2 deviations to the left and 2 deviations to the right. Area is 1. This is also equal to 0.9545. What I am trying to emphasize is that you may sometimes see percentage, sometimes you will see this thing in terms of decimal. That is why normal, there is a lot of difference in representation and how you would want to show it, but you just have to understand what it is, and then you will be able to write the correct answer. What will happen when I move from mu minus 3 sigma to mu plus 3 sigma? Okay, 3 deviations. When I move to 3 deviations, from here to here. Okay, this is 3 deviations. 3 deviations to the left and 3 deviations to the right. Now what happens? This is 34.135 plus 13.59 plus 2.14. How much is that? 49.865 into 2. So this is equal to 99.73% of area. And what is the area of 1? So this is equal to 0.9973. So what this means is, after I have moved 3 sigma away, what is the area left? This minus this. That is remaining area not covered under mu plus or minus 3 sigma is equal to 0.27%. Is equal to 0.27%. So can you imagine that most of your data, most of the information is going to lie between mu minus 3 sigma to mu plus sigma. Apart from that, only 0.27%, which is equal to 0.0027 of the area. Okay, so very small, so that if I am able to study from mu minus 3 sigma, my whole data will be covered under it. Okay. Yes, Saima, I hope you have understood now. Yes, Goodlin, thank you to you. Bhavna, you should know these values, yes, because these are very critical values, so you should be knowing them. Okay. And see what happens when you practice more and more sums, you don't even have to remember. Automatically, you will think about 34.135, 13.59, okay, those type of things. And sometimes there may be a slight variation in the numbering. Okay. Now here it is 68.27. When I calculated, here they are saying 6828. Okay. So that small variation is okay. What you must remember is, okay, this thing is gone. You must remember these formula. This formula is very important. That is, I will write it again. Mean deviation is equal to 0.8 times sigma. Q1 is equal to mu minus 0.675 sigma. Q3 is equal to mu plus 0.0675 sigma, and QD, quartile deviation, is equal to 0.675 sigma. Okay, this you should know. And like we had the additive property for binomial distribution. Poisson distribution, then if you have x and y as independent normal variables, so what happens for x? We have mu1 and sigma1 as the parameters, and for y we have mu2 and sigma2 as the parameters, then you can combine these two distributions, and here the normal distribution will be of mu1 plus mu2. Okay, simple addition, but for standard deviation it will be square root of sigma 1 square plus sigma 2 square. Okay, you will have this as the parameters. So what will be the parameters when x, which is a standard normal variate, and which is normal variate with mean as mu1 and standard deviation as sigma 1, and then we have y with mean as mu2 and standard deviation as sigma 2. Then we will have when I combine these two, we will again have a normal variate with mean as mu1 plus mu2, but standard deviation as square root of sigma 1 square and sigma 2 square addition. Now, where do we use it? It is normal distribution is not only used in statistics, it is also used in social science subjects, management, commerce, etc. When the number of trials of a binomial is large and P, the probability of success is moderate, that is neither too large nor too small, then the binomial also tends to normal. Okay, so this is the approximation. This you can get for theory. Okay. What happens when binomial to Poisson? We say that NP is finite. Okay, remember the word finite. Here what you are saying is it is moderate, that is neither large nor small. Then we say binomial tends to the normal distribution. Poisson also for large values of m approaches normal distribution. Okay, so this is also important. Poisson also does it for large values of m. It is possible. Okay, such transformation become necessary as it is easier to compute probabilities under assumption of a normal distribution. Not only the distribution, the probability distributions of T, chi square and F also tend to normal distribution. Now, another very important thing that you use in by solving the sums is when they will give you a range A, x lies between A and B, then you will find out first the value of B minus mu upon sigma. Okay, and from there, from this you will minus phi of A minus mu upon sigma. Okay, that is, this upper limit comes first and the lower limit comes afterwards. Okay, just remember that. This you will be needing more in sums, so you don't have to remember all this, the symbols, etc. Remember, whenever you have that, you will first write the second term's value and then minus the first term's value. I've just written it again. Lakshita, don't go into all this. Just remember that this will be for a theory question. Okay, there are lots of good books on statistics that you can refer to if you're interested in that subject. Okay. Yes, Sagar, nice explanation. Thank you so much. Yes, Bhavna, I hope now things are getting clearer. The more we solve, things will become better. So we're just revising the formula again. So here we are saying fx is equal to 1 upon sigma square root of 2 pi e raised to minus x minus mu square upon 2 sigma square, where x is lying between minus to plus infinity. Okay. Now if I put mu is equal to 0 and sigma is equal to 1, then I get f of z to be equal to 1 upon square root of 2 pi, okay, e raised to minus z square upon 2. Okay. The condition will remain the same. Minus infinity less than z less than plus infinity. Okay. Now let us see what the theory questions are. The most important continuous probability distribution is the normal distribution. Okay, this is more important than T and sampling. Then the probability density function of a normal variable is given by. Okay, always these questions you get so excited and then you may make a mistake of picking the wrong answer. Just read all the 4 options clearly. Okay, just understand them and then take the correct answer. So here we know fx is equal to 1 upon sigma square root of 2 pi into e raised to minus x bar minus x minus mu square upon 2 sigma square. Okay. Now here, let us see over here. Now here, this condition, minus infinity to plus infinity. This is there for here. Here it is written 0 to less than x less than infinity. So this option automatically goes away. Here they have again written. Okay. So this is quite possible. This is possible. A and C are possible. B is already out of the race. And if ABC is not there, then only we'll consider D. Now we have to choose between A and C. Let us see what happens. So here 1 upon sigma into square root of 2 pi. Here what have they written? Square root of 2 pi sigma. So this is not the correct answer. So A will be the correct answer. Okay. Has everybody got this answer? Lakshita, it is sigma. Okay, it is sigma, that is standard deviation. If I want to talk about variance, I will talk about sigma square. Okay. Yes, Zeba. Wonderful, wonderful. Bhumika, Zeba. Yes, 28A is the correct answer. Yes, Bhumika, understood, Sagar? Can we do the next one? The total area under the curve is how much? Just put in the correct answer. Yes, have I got? 29A. Very good. Okay. Total area is 1. Okay. Not 50%, not 0.5, not any value between 0 and 1. It is the total area under the curve is equal to 1. Okay. Next 30th question. The normal curve is, okay, it is which? Yes. 30th answer. Sakshi. Yes. Very good. It is bell shaped. Okay. Yes, Sakshi. Bell shaped. The normal curve is positively skewed, negatively skewed, symmetrical, all of these. Yes, 31 answer I want. Those of you who have forgotten, let me take you to that property. Okay, we have that property. Okay, the normal distribution is symmetrical about x is equal to mu. As such, its skewness is 0. Okay, so when we are talking about the 31st, the normal curve is yes, Sahaspreet, Himanshu. 31. What is the answer? Zeba? Yes, symmetrical. Okay, very nice. Okay, it is neither positively skewed nor negatively skewed. It is symmetrical. What is the area of the normal curve? Between minus infinity to mu, it is 0.5. Between minus infinity to plus infinity is 0.5. Between this and this. Okay. Now here, see the C, minus infinity to plus infinity. What is it saying? Area under curve is how much? Equal to 1. So under curve means what? From minus infinity to plus infinity, it is equal to 1. So C is already gone. Now A, B and D. What are they saying? Minus infinity to mu, it is 0.5. Is this correct? Yes, this is correct. Why we are saying? Because the curve is symmetric and the line x is equal to mu divides into it into two equal parts. Divides the curve. Okay, divides the curve into two equal parts. So minus infinity to mu is 0.5, correct. Between mu and in plus infinity is 0.5. This is also correct. A is also correct. B is also correct. So D is the correct answer. Yes, very good. For those who have already answered, very nice. Diksha, yes, 32 D. Sudhanshu, yes, C. Pratidnya, C. Chahal, 32. 32 is D, Chahal. Okay. Yes, Gurleen. Okay, now 33rd. The cumulative distribution function of a random variable x is given by which of this? A cumulative distribution function is given by what? So 33rd. Yes, we have just done the properties, right? Cumulative distribution function. Remember, we wrote it down. Okay, here. See, everything I have, whatever the questions are, I have already shown you the answer. So here, pi x, p of x less than or equal to x is known as the cumulative distribution function. Okay, so x less than or equal to x. So that is why it is important that you solve the problem so that you will appreciate whatever information is given above, you will be able to understand. So A will be the correct answer. Okay, x less than or equal to x. Okay. With A and B, I don't know what is different they have given. Same, I think there's some printing mistake, so they both are the same. Okay, it is capital X. Okay. Okay, P phi of x is capital X is less than or equal to small x. Okay, so A is the correct answer. 34. The mean and mode of a normal distribution may be equal, are always equal, may be different. So are always equal. We know that mean is equal to mode is equal to median for a standard, for a normal distribution. The mean deviation about median of a standard normal variate is. Okay, so that is why you must remember mean deviation is how much? 0.8 times standard deviation. Q1 is how much? Mu minus 0.675 sigma. Q3 is mu plus 0.675 sigma. Okay, and quartile deviation is equal to 0.675 sigma. Okay, we already have this formula. So the mean deviation about median will be A, B, C or D. Which of them? Okay, what is this? This value is equal to quartile deviation. This is just a number. Okay, so this is not correct. Then 0.8 is also a number. This is also not correct. This C will be the correct answer, right? Yes. So 36, can you give me the answer? Yes, 30. Sudhanshu, correct. 34 is correct for you. Swati, 35. 35. 0.8 times sigma will be the correct answer. Yes. Yes, Bibhu, correct. Sayed, correct. Faizan, correct. Faizan, C is the correct answer. Yes. Sakshi, Pratidnya. Pratidnya, that is quartile deviation. Yes. Okay, 36. Diksha is saying B. 36 Diksha, Sakshi is saying 36C. Okay. 36. The quartile deviation of a normal distribution with mean 10 and standard deviation 4 is. Okay. Now mean is 10 and standard deviation is 4. Quartile deviation is equal to 0.67 into sigma. Okay. 0.675 sigma. So 36 question we are doing. So 0.675 into sigma. Sigma is 4. 0.675 into sigma is 4, which is equal to 2.7. So C will be the correct answer. Okay. So this over here, here 0.675 into sigma. Sigma is equal to 4. Okay. So into 4, which is equal to 2.7. Right. Then 37. For a standard normal distribution, the point of inflections are given by. What are the points of inflections? This is equal to mu plus or minus sigma. Okay. Mu plus or minus sigma. Now for a standard normal distribution, what is the condition? What is the condition? What is the value of mu? It is 0. What is the value of sigma? It is equal to 1. Now here, points of inflection will be equal to 0 plus or minus 1. So what will the points of inflection be? 1 and minus 1. So this will be 1 and minus 1. So C will be the correct answer for 37. Okay, Diksha. Yeah. That's by mistake you wrote B. 36, option C, Gurleen, correct. Himanshu, 37. Yes, Himanshu. That is the formula. Point of inflection for a normal distribution is standard normal distribution is given by mu minus sigma minus mu and sigma. Mu minus sigma and mu plus sigma. Sudhanshu, for that you have to see what the standard normal variant is. Okay, we have done that. Standard normal variant. Okay. Don't forget, when we are doing this, you should pay attention, right? When do we say it is a standard normal variant? Sudhanshu? Okay, this is standard normal. You should also write down in your study material. standard normal variate. What is the condition? When do we say it is a standard normal variate? When we take mu is equal to 0 and sigma is equal to 1, then we get this formula. This is the formula for standard normal variate. And here we say it is a standard normal variate. Now, normally quartile distribution is given by how much? 0.675 into sigma. Okay. Now here what will happen? Sigma is 1. That time you will have quartile deviation to be equal to 675 for standard normal variate. Okay. In 37 sum, what are they asking us? They are asking points of inflection. Now points of inflection are given by mu minus sigma and mu plus sigma, and so we are able to find it. Okay. So then I hope you've understood. Madiha, correct? Yes. 38. The symbol phi a indicates the area of the standard normal curve between what? Yes, 38. What is the answer? 38. What is the answer? The symbol sigma phi a indicates the area of the standard normal curve between 0 to a to 0, a to. Yes, 38. Just go back to the points, okay? Yes, Lakshita. Let's go back to the points and see. The symbol phi a indicates the area of the standard normal curve between. Where did we do standard normal curve? Okay, standard normal curve. Okay, what is the phi saying? What is phi x is? Phi x is equal to p x less than or equal to small x. Okay. Now we have here phi of 0 like is p x is less than or equal to 0. So here what do we have? Phi of a. So it will be p x is less than or equal to a. So what does it mean? It means that from minus infinity to a. Okay, it means what? We are talking of the curve between minus infinity to a. Okay, so use this over here and get into the 30th sum. So this will be minus infinity to a. The interval mu minus 3 sigma and mu plus 3 sigma covers what? When is 95% area covered? 96, 99. What about this? This is the area outside mu plus or minus 3 sigma. Okay. So for this question, I've again shown you this. The intervals mu minus 3 sigma and mu plus 3 sigma is where here you can see mu minus 3 sigma. So this is the line. And mu plus 3 sigma, this is the line. Okay, and what do I want to find out? I want to find out from here to here. So what I do, I add them up. So when I add them up, so this is 2.14. This is over here 34.135 plus 13.59 plus 2.14. 50.175 is only half of it into 2 that I get into 2. So 34.135 plus 13.59 plus 2.14 is 49.85 into 2, that is 99.79. Okay. So the interval gives you 99.79. So this is the closest answer that we have. Okay, is that clear? I'm going very slowly for you to be able to understand this completely. 38. So the symbol phi indicates the area of the standard normal curve between. Okay, just go to that point. This is standard normal variate. You have phi of x will be p x of less than or equal to 0. So here what do we have? We have phi of a. So it will be p x less than or equal to a. So up to a. From where will it reach up to a? So this is your number line. This is your 0. And this is your a. Okay. So here what is happening? Where are we going here? Minus infinity. Here what are we going? Towards plus infinity. When I'm saying this x is less than or equal to 0 in this case, but over here we have phi of a. So that means from minus infinity, I'm reaching a. Okay, from minus infinity, I am reaching a. So this is why we say minus infinity to plus a. Okay, Gurleen, hope you've understood. Okay, here also we took the area, we calculated and we said that out of 95, 96, 99 and 0.27, C is the best answer. So we have selected C. Now, if x and y are two independent normal random variables, then the distribution x plus y is what? 43rd, can you give me the answer? Yes, Himanshu, correct. 43, Diksha. Yes, Bibu, correct. Yeah. Diksha is saying 43A is the correct answer. Okay. Because here also we have talked about the additional properties. Okay, here. Okay, when we have two independent normal variables, yeah, and you want to find it together, okay, then z, which is equal to x plus y, will also be a normal. Okay, that is what they are trying to tell you. With mean how much? Mu1 plus mu2, and standard deviation is square root of sigma 1 square plus sigma 2 square. This what you have done as the 8 point in the in your properties of normal distribution. That itself we are using here. Okay, that itself we are here. X and y are two independent normal variables, and the distribution x plus y will also be a normal. Okay, here I have already written it for you. Now, let us go to the sum. Now, this is the 20th sum in the book. For a random variable x, the probability density function is given by this. Find out the probability distribution function. Okay, 39th here in the book, this D is given as the answer. So you can do it this way, or it is covering all area except for 0.27. Okay, except for 0.27. So you can take this also. They will not give you something that is so close in the in terms of answering, but here but all but 0.27 is also the correct answer. Okay. Yes, Bala. Okay. So now let us talk about the question that we are doing. We want to find out this. Okay. Now let us see the formula. What is the formula for fx? Fx is equal to 1 upon sigma square root of 2 pi e raised to minus x minus sigma square upon 2 sigma square. Now here you can see that here you can't see this 2, and here also you can't see this 2. Okay. So here what we do is we will rearrange. Okay. Rearrange the term. Okay. We are going to rearrange the term. So what I do is I write down fx is equal to e raised to minus x minus 4 whole square. This I already have over here. Upon 2 sigma square I don't have. So what I do here, I don't have anything. So what do I introduce? I introduce 2 into 1 half. So 2 cancels. So what will I have in the denominator? 1 only. So here what I am writing, instead of writing 1, I am writing 2 into 1 by 2. Okay. Upon 1 upon, this is square root of pi. So instead of that, I am writing square root of 2 pi into 1 upon 2. 2 pi into 1 upon 2. What do I have here? I simply had square root of pi. Instead of that, I am writing 2 into 1 upon 2 square root of into pi. Okay. So what will happen once I have this? I will write this as this is equal to 1 upon. Now what do I require? I require 2 pi under the square root sign. So 2 pi I have under the square. I want to take out this 2 outside the square root sign. When I am bringing something inside the square root sign, outside it becomes double. So this is equal to 1 upon 4 square root of 2 pi. This is equal to 1 upon 4 square root of 2 pi. E raised to, this is what? E raised to x minus 1 by 4 square. Okay. So minus e x minus mu. So x minus 4 whole square upon 2 into sigma square. So 2 already I have. So 2 into sigma square will be 1. Okay. So what do I get when I compare this formula? When I compare this formula over here, instead of sigma square, what do I have? I have instead of sigma, what do I have? I have 1 by 4. Instead of mu, what do I have? 4. Okay. I'm comparing the formula that I have with what I have rearranged. Okay. Why did I rearrange? Because I want to write this in exactly like the formula that I have. From this, what do you get? You get the value of mu to be equal to 4. You get the value of mu to be equal to 4. What about sigma square? Sigma square will be 1 half. So this is a probability density curve with mu is equal to 4 and sigma square is equal to half. Okay. This is just that you need to rearrange. Okay. Yes. Says Preet, yes. Prathusha, yes. Correct. Vaishnav, yes, correct. Sama, you've understood. Abhinav, correct. Okay, next sum. If the two quartiles have a normal distribution of 47.30 and 52.70, what is the mode of the distribution? Okay. Now let us first write down the formula. Q1 is equal to mu minus 0.675 and Q2 is equal to mu into sigma mu plus 0.675 into sigma. Okay. Now we have been given the value. This is Q1, this is Q3. What is the mode? So here they are checking that whether or not you know the formula for Q1, Q3. Also, they are checking also whether or not you know that mean is equal to median is equal to mode for a normal curve. Okay. So here, once I find out mu will also be equal to mode. Okay. Mu will be equal to mode. So all I need to do is I need to solve Q1, Q3, not Q2. This is Q3. And then I will be able to get the value of mu. Now, Q1 and Q3, the equations are what? They are simple simultaneous equation. So I substitute. Instead of Q1, what should I write? 47.3. 47.3 is equal to mu minus 0.675 sigma. I don't know mu, I don't know sigma. And 52.7 is equal to mu plus 0.675 sigma. Adding the two equation, what will happen? Adding the two equation, this is what? Minus 675 sigma. What is this? Plus 675 sigma. They will cancel out. Okay. They will cancel out. So what will be I left with? 47.3 plus 52.7. 100, I think, no? 47.3 plus 52.7. That is 100 is equal to 2 mu. Or mu is equal to 50. That is mean equal to mode is equal to 50. Okay. Once I know this, I can easily find out sigma. Okay. Find the mean deviation about median of this distribution. Okay. What is mode? I have answered. What is mean deviation? I have to find out. What is this? This is equal to, let me first write down the equation. So 47.3 is equal to mu minus 0.675 sigma. Okay. Now what happens is I have found out the value of mean to be equal to 50. This is equal to 50 minus 0.675 mu. 47.5. So solving this, I get 0.675 sigma is equal to 50 minus 47.5. 47.5. And sigma will be equal to, how much is 50 minus 47.5? Minus 47.5 is equal to 2.5. So 2.5 divided by 0.675 divided by 0.675 is equal to 3.7. Okay, so here we have found sigma. What is the mean deviation? Mean deviation is equal to 0.8 times sigma. So 0.8 into 3.7, which is equal to into 8 into 0.8. Sorry. 0.8 into 3.7, this gives me 2.96. Okay, which is nearly equal to 3. So depending on what options you have, you will tick the correct answer. Okay, 47.3, not 47.5, 47.3. Here, thank you for pointing it out. 47.3. This is 47.3. So 50 minus 47.3. 50 minus 47.3, you get 2.7. That divided by 0.675 gives you 4. Okay, it's already given you 4. Okay, so I don't have to worry. Is equal to 4. So this into 4, which is equal to 3.2. So this is what we get with solving this. Yes, Sprit, you can do that also. You can just one and the same thing over here. This is also sigma. Sigma is 1 by 4. Here also 2 sigma square. So 2, we already have sigma square is 1 by 2. So sigma square is 1 by 2. So sigma will be square root of this thing. Okay, sigma is 1 by 2. So sigma will be equal to square root of 1 by 2, which you know is will be equal to square root of 1 by 4. Or not square root, it will be equal to simply 1 by 4. Okay, same thing we have done. Okay, now let us find out the points of inflection. Now here, what do we have? This can be written as 1 upon 4 square root of 2 pi into e raised to minus x minus 10 whole square into 2 into, how much is this? 32 will be 2 into 16. Okay, this is 4 and this is 16. Okay, so 4 is equal to sigma and 16 will be what? Sigma square. Okay, 4 is sigma and 16 is sigma square. So what happens is that this gives me the value of sigma. What is the value of mu? Mu is, what is the formula? We have 1 upon 2, 1 upon sigma square root of 2 pi e raised to minus x minus mu whole square upon 2 sigma square. So I have found out from here that mu is equal to 4, sigma is equal to 4. What will be the value of mu? Mu here is x minus mu. What is here? X minus 10. So mu will be equal to 10. Just by observation, okay, just by inspection, you will be able to find out what is the value of mu and what is the value of sigma. And what are the points of inflection? First point will be mu minus sigma. Second point will be mu plus sigma. Okay. This is equal to how much? This is equal to 10 minus 4, which is equal to 6. And this is equal to 10 plus 4, which is equal to 40. Okay. So this is a way you can solve this sum. Okay. Have you understood the points of inflection? Points of inflection are the point where the curve moves from concave to convex or convex to concave. Yes, very good, Lakshita. 6 and 14, Himanshu, Bhumika. Yes, says Preet. The Bhumika understood Zebba, Sakar. Excellent. Okay, X follows normal distribution with mean as 50 and variance as 100. What is P greater than or equal to 60 given that pi of 1 is equal to 8.4? Okay. See, what I will do is I will take you to the book because here I want you to follow, understand how to use the biometric table. Okay. Let us see 16.24. Okay. I hope all of you can see this. Okay. Just let me know whether you can see example 16.24, the solution in your study material. Is this visible? Just let me know in the chat box whether you can see this. Very good. Now you can see this. Now see what they're saying is X follows a normal distribution with mean of 50 and variance of 100. What is P greater than or equal to 60 given that phi of 1 is equal to pi of 1 is equal to 0.8413. Okay. What does this mean? Okay. Here they are given you that mu is 50 and sigma square is 100. Okay. They've already given you variance as 100. Now, whenever you want to find Px greater than or equal to 60, you need to find it in this manner. Okay. Greater than, it will be 1 minus P of less than or equal to 60. Okay. So that because you're trying to find greater than 60, you just have to say 1 minus the area under onto your left hand side. So when you say that, that means that where is your X greater than or equal to 60 means X minus 50 upon 100 upon sigma. Okay, you need know that X minus mu upon sigma. So X minus 50 upon sigma. What is sigma? Square root of 100. Okay, sigma square is 100. Sigma will be 10. Okay, so upon 10 less than or equal to, how much it will be? X minus mu. So this will be equal to x minus 16 upon 10. Okay, this they are saying what? This is equal to phi of 1. Okay, this we know. This is 50 minus 50. And here it is x minus, not 50. Just a minute. We have, what is the value of x? X is 60. Yes, x is 60. So this will be 60 minus 50 upon 10. Okay, 60 minus 50 upon 10. What is 60 minus 50 upon 10? This will be equal to, less than or equal to, 60 minus 50 is 10 upon 10. What is this? This is nothing but 1. So this is nothing but 1. So we say that 1 minus p x less than or equal to 60 will be equal to 1 minus phi of 1. Okay. Because we got this as 1, this is nothing but phi of 1. Which value you already have? 0.8413. So, which is equal to 0.16. Okay. So, whenever you have this, what is given to you? It is given to you as, they want you to find the area x greater than or equal to 60. Now, how do I represent z? Z is given by x minus mu upon sigma, x minus mu upon sigma. So what will happen? This is equal to x greater than 60 can be written as 1 minus p x less than or equal to 60. Okay. P greater than or equal to 60 is written as 1 minus p x less than or equal to 60. Why we do that? Because x is, there is no limit to x. X will go to up to minus infinity. Then I am faced with a problem how to calculate. So instead of doing that, like we did in some probability, at least 5 means what we do? At least 5 means we did 1 minus p, P0, P1, P2, P3 up to P4. Okay. Once I do that, I can find out at least 5. Okay. So same thing over here. We are asking for x greater than or equal to 60. Then what do I do? From 1, that is the total area, I subtract how much? P less than x less than or equal to 50. So what is the situation here? So it will be x will be 0 to. Now if I write 50 minus 50 upon 10, up to where? Up to what am I going? 60 minus 60. 60 minus 50 upon 10. 60 minus 50 upon 10. 50 minus 50 upon 10. 50 minus 50 is 0. 0 upon 10. So this is 0. And less than or equal to how much? 60 minus 50 is 10. So 10 upon 10, that is 1. Okay. So this is equal to 1 minus p of 1. Okay. This p of 1, phi of 1 is already given to you as 0.8413. So 1 minus 8413, you will get it as 0.16. Okay. This is how you will do this sum. Okay, so have you understood this? Sum 16.24. Yes, Vaishnav, you can do that also. Okay, absolutely correct. See, whichever way you are comfortable, you can do that. If the random variable x follows normal distribution with mean as 120 and standard deviation as 40, what is the probability that x less than or equal to 150 is given that x is greater than 120? Okay. I hope you can see the screen here, 16.25. You can see it. Yes. Bhumika clear? Sagar clear? Bala? Yes? Okay. So let us look at this other sum. Okay. Now what we know is, how do I write Z? Z is mu minus sigma up, x minus mu upon, sorry, we write it as x minus mu upon sigma, right? This at least you remember. Now what they are saying is that x value is greater than 120 and x will lie up to 150. Okay. So what is the minimum? That is 120 minus mu upon sigma. And what is the final value? It will be x minus mu upon sigma, and maximum will be 150 minus mu upon sigma. Okay. Now they have already given you as mean as 120 and deviation as 40. Okay. Now this limit you have understood, 120 to 150. How do I put it? So here, what is the value of mu? 120. What is the value of sigma? 40. So 120 minus 120 upon 40, x minus 120 upon 40, and here it is 150 minus 120 upon 40, right? Up till here you have understood, this is my lower limit, this is my upper limit. Now what will this be? 120 minus 120, this is 0. What is this? X minus 120 upon 40. What is this? 150 minus 120 is 30 upon 40. Now what is 30 upon 40? How much is 30 upon 40? It is nothing but 0.75. 30 upon 40 is nothing but 0.75. Okay, 150 minus 120 is 30. 30 upon 40 is 0.75. So that this P of Z is how much? In the numerator, what will I have? In the numerator, I will have P of 0.75 minus P of 0. Okay, this is my 0. This is my 0.75. Okay, this is pi, not P. Pi of, and pi of 0. In the denominator, I have x greater than 120. Always we write, when we have P, x greater than 120, what should we write this? This is equal to 1 minus P of x less than or equal to 120. Okay, always greater than we are writing like this. Now how much is this? X less than or equal to 120. That is, we will have 1 minus P x less than or equal to 120. Okay. So numerator I have solved, denominator will be, again I will be solving, and then we will be using the tables. Okay. So till here, have you understood? So 0.75 minus pi of 0, 1 minus pi of 0. Okay. So that here I'm trying to show you as per your book also, so that what I'm solving you can see from the book also, from your study material also. Pi of 0 and 1 minus P of pi of 0. Okay. Why? Because 120 is there. 120 minus 120 is 0. 0 upon 40 will be 0. Okay. Now here, now where is your biometric table? Now we want to find what? We want to find 0.75. Okay, 0.75. Area under the curve. Okay, we are trying to find out area under the curve for pi of 75. Okay, for pi of 75, what do we do? So this is my number line. This is my 0 and this is my 0.75. Okay, here what will happen? This is minus infinity to here. Now what happens from minus infinity to 0? What is the area? From here to here, what is the area? This is equal to 0.5, And from here to here, this is what I need to find out. Okay. From 0 to 0.75, I need to find out. Other than that, this is 0.5, I already know. Okay. So for that, I will go to the biometric table. This is, let me increase this. Point 0.75. So this is my, okay, they will not let me. Yeah. This is my 0.7. From 0.7 I go up to where I should go? Up to 5. So where is my this? Okay. 0.7 and plus 0.05. 0.70 plus 0.05 gives me 0.75. So 0.7 up to 0.5. What is the answer? 0.2724. Okay. This is what we have to add to 0.5. This is what we have to add to 0.5. Okay. So up point here. So you will have area will be equal to 0.5 plus 0.2734. Okay. Where does this 0.2734 come? From the biometric table, 2734. Why have I taken this? Because I have to find phi of 0.75. So 0.7 here and 5 on the column. Like we do in logs, anti-logs, right? From the left, we take some figure, some row, and we select the column. And where the row and column intersect, that will be your value. So phi of 0.75 will be here 0.2735. But don't forget to add the 0.5 because we are going from minus infinity up to that point. So we have this to be equal to, okay, this is equal to, so this is equal to 0.7734. Okay, this is the area for, because what we are trying to find out, we are going to finding out 0.75 minus 0.5, okay, upon 1 minus pi of 0. Okay, pi of 0 we already know is 0.5. Now 0.75 we have found out to be 0.7734. So this is 0.7734 minus 0.50 upon 1 minus 0.5 is 0.50. So once I solve this, I can divide and I will get the answer. This is 0.7734 minus 0.5 divided by 0.5. You get as, this is 0.5468, which is nearly equal to 0.55. Okay. Is that clear now? How you have to use the biometric table? Okay. So whenever you are dealing with positive numbers, remember that this area, see, we are talking about positive numbers. So this area, because this is my 0, here I have negative numbers and here it is positive. So whenever I am trying to find a positive number, what will I do? This area will already I know is 0.5. Then I will need to find out only this much area. Okay. So in this case, this much area was how much? 0.2734. So this area plus this area plus this area giving me 0.773. Okay, this is known as what? It is known as area under the standard normal curve. Yes, Sagar. Understood, Zeba. Correct answer, Bibu. Correct. Yes. Okay, so this is how you are supposed to be doing the sums. Okay, so say similar sums you will have. Okay, here also, so just try to substitute the values and find the area under the curve. You will get the answer. Okay. So thank you all for your patient hearing. It was a wonderful session with you. I hope now you've got the concept clear. Try to solve the sums. If not, go back to the videos, see and once you've understood, just like the video that so that we also come to know how many times you have watched it and whether or not you have understood it. Okay? Yes. Yes, Himanshu, happy Dashera. Thank you. Thank you so much. Yes. It doesn't matter. Someday prayer it's always welcome, Good wishes are always welcome and all the very best for your studies. Yes. Saima, you missed in the initial time. So just what you do is revisit the video, see the starting points, because in the starting points we have dealt with all the properties that we are using now. Once you understand those properties, you will be able to solve it. Okay, because I remember last time for binomial and Poisson, Saima, you are giving very good answers, so you will be able to do it. Yes, Sagar, thank you. Thank you. Even I enjoyed teaching you. Soumya, thank you. Yeah. Zaba, thank you. Thank you. Have a great day ahead. Thank you.